Hey guys, this video is going to go over solving quadratics by factoring. So previously we have learned how to solve quadratics by graphing. So that is the first way we learned how to solve quadratics, and there's actually 5 different ways to solve it, and this is the second way that we learned how to solve quadratics. Now our essential question is, how are the solutions of a quadratic related to its factors? So back in Unit 6, we learned how to factor trinomials and how to factor quadratics. So we're going to apply that to this lesson. Now, again, we're solving quadratics here, so we're not just factoring, we're actually solving them as well. So you don't want to stop after you factor. That's probably the most common mistake, is that once we finish factoring, we stop. But the instructions were that we need to solve the quadratic by factoring, not just factor it. All right, so let's go and hop into this. So when you're asked to solve a quadratic, you are asked to basically find the x-intercepts. When you're asked to find the solutions to a quadratic, you're asked to find the x-intercepts, or in other words, solutions. Now remember, the other words for x-intercepts for a quadratic are roots, zeros, and solutions. So when you're asked to solve something, you're usually asked to find the solution. Well, what's the solution of a quadratic? That's its x-intercept. So if they're asking you to solve something, you're solving for the x-intercepts here. All right, now before we go over why factoring is a way for us to solve, let's go over the zero product property. Now this is a property that basically says that if a times b equals 0, then there's 3 things that could possibly happen, right? So if I multiply 2 numbers, if a times b equals 0, then either this number is 0, or b is 0, or they're both 0, right? Like the only way for 2 numbers to multiply and make 0 is if one of them 0, the other one's 0, or that they're both 0. So either a equals 0, b equals 0, or they both equal 0. Okay, so the only way for 2 numbers to multiply again to make 0 is either one of them 0, the other one's 0, or they're both 0. So that's the only way that you would have 0 here. Now, remember that an x-intercept is number comma 0, right? That's an x-intercept, number comma 0. So if I'm solving for an x-intercept, I know that every single time my y value is going to be what? It's going to be 0. All right, so I'm going to go ahead and go through number 1, but the first thing I'm going to do is I'm going to actually show you the steps first. So step 1, the first thing you want to do is you want to get one side equal to 0. All right, so as you notice, most of these equations are equations, right? There's equal signs there, so they are equations. But we want one side to be 0. So we want everything on one side so that one side is equal to 0. Kind of like when we're graphing, we want one side to be equal to 0 as well. The second step after you do that, is you want to factor. So you're going to use your skills from Unit 6. So you're going to factor with AC method, and so that's what you want to do. Always check for a GCF, right? First thing you do is check for GCF. Second thing you do is you factor with AC method if possible. Sometimes you have those special cases. So again, there's certain times where we have certain things, so you just want to keep that in mind. Now, once you factor, what you're going to do is you're going to set all of your factors equal to 0. Okay. Next step is you're going to solve for x. Because again, what is it solving a quadratic means? You're solving for the x-intercept. So we're solving for x here, solving for that x-intercept. And then lastly, I want you to write it as points. Oops. Now, on your STAR test or on some tests, so on the STAR test, when you have multiple choice answers, they're not always going to write it as points. They might just write the x value, which is still fine, but I would prefer that you write it as points so that you know they are x-intercepts. We're going to write them as points. Okay? All right, so those are our 5 steps. We're going to get one side equal to 0. So the first thing in number 1, I have x squared plus 7x equals 18. The first step is I need one side equal to 0. So the easiest thing for me to do is to move that 18 to the left side. So the first thing I'm going to do is I'm going to subtract 18 from both sides, right? So on this right-hand side, I now have 0. That's the goal, right? We want to have 0 on one side. So I have x squared plus 7x minus 18. Now I want to keep it in this order because when I factor, I need it in standard form. When I factor, I want it in standard form, so I want 8x squared plus bx plus c. So I want ax squared, let's do a different color actually. Ax squared plus bx plus c equals 0. That's basically the format we want here. We want all of our stuff on the left side, if possible, and then 0 on one side. So you want one side equal to 0. And again, your left side can equal to 0 as well. It doesn't have to be the right side. Once you get to this step, once you get all your terms on one side and one side equal to 0, then you factor. Well, first thing you always check for is a GCF. So you're going to ignore this equals 0 for now. It's going to stay there, but you're going to ignore it for now. On this side, I have 3 terms. No matter what I do, anytime I factor, I always check for a greatest common factor first. Do we have one? We have a greatest common factor of 1, but remember, dividing out of 1 is kind of pointless. It doesn't make any sense. So we move on. We're like, okay, well, let's do our AC method. Okay, so let's identify our values, all right? So A here is 1, B is 7, and C is negative 18. So let's factor this. So remember, it's called AC method because AC goes on top, B goes on the bottom. So A times C here, so 1 times negative 18 is going to be negative 18. And your B is 7. So I'm looking for 2 numbers that multiply to negative 18 but add to 7. And that's going to be positive 9, negative 2. Positive 9 and negative 2 multiply to make negative 18 but add to make positive 7. So you want to make sure it satisfies both of those conditions. So remember, when you factor, that first term stays the same, right? X squared is going to stay the same, and minus 18 is going to stay the same. All that's happening is that this middle term is being split. That's the whole reason why we're doing AC method. So you have plus 9x minus 2x. Okay, remember those numbers come from here in our sides of our x here. Oops, sorry, I got an email. All right, now again, that equals 0 is kind of irrelevant for now, but we're going to keep it there. So just keep it there until the very end. You don't want to forget about it because again, we're solving quadratics here. We're not just factoring. We're not in unit 6 anymore. We're actually solving stuff. All right, now once you're with here and you have 4 terms, you can now factor by grouping. So I'm going to split my terms down the middle into 2 groups, and then I'm going to factor by grouping. In my first group, my greatest common factor would be 1x, because it's the largest thing I can factor out of both. X squared divided by x is going to leave me with a single x. 9x divided by x is going to be positive 9 because those x's cancel. And then I close my parentheses. Moving on to the second set of parentheses. Okay, the greatest common factor, or the greatest thing that goes into both terms here would be positive 2. But because that first term is a negative, you must take out a negative 2. Remember, if the first term in your group is negative, you must take out a negative number. So negative 2 is going to go out here. And then in parentheses, I have negative 2 divided by negative 2 gives me positive 1. So I have positive 1x, because the x stays. And then negative 18 divided by negative 2 is positive 9. And then again, we're going to leave it here equals 0. So we haven't done anything with that 0 yet. We're almost done factoring. We're super close, but we're not quite done yet, right? So our next step here is we want to put our 2 greatest common, our 2 GCFs into a set of parentheses. So one of our factors is going to be x minus 2. So that's one of our factors. The other factor is going to be one set of the matching. So this would be x plus 9. And lastly, equals 0. So notice how I kept equals 0 on the entire thing. You want to keep it on the entire thing because we need it to actually solve, but we just don't need it yet. So that's why we haven't seen it come in play yet. All right, once you get here, in unit 6, you'd stop, right? Like this is where you would stop in unit 6. I factored it, I'm finished. But we're solving here. So when you're solving, you got to actually do a few more steps. So we did the first step. We got one side equal to 0. Then we factored. Right? We factored here. That's our step here. Then it says set all factors equal to 0. So I'm going to move this up here to this line up here because I ran out of room. So I'm going to paste here. Okay. I'm just going to draw an arrow stating that I'm continuing on. All right. Oops. All right. So here we are. It says set all factors equal to 0. So here we have 2 factors. X minus 2 as a factor, and x plus 9 as a factor. So you're going to set them all equal to 0. So remember what I said earlier with the 0 product property. If something times something equals 0, then either the first something is 0, the second something is 0, or they're both 0. Here I have x minus 2 times x plus 9 equals 0. So either x minus 2 equals 0, x plus 9 equals 0, or they both equal 0. So you're going to set them all equal to 0. So take x minus 2, set that equal to 0. This is where the equal to 0 comes into play. Then you have x plus 9, you're going to set that equal to 0. So you're going to set all of your factors equal to 0. Once you do that, right, we did that step, we're going to solve for x. So we're trying to get x by itself. So what color have I not used yet? This one. Okay, so let's get x by itself in both situations. So in order to get x by itself on this left-hand side, I would add 2 to both sides. So I get x equals positive 2. On this right-hand side, to get x by itself, I would have to subtract 9, and I get x equals negative 9. You're like, well, what did I just solve for? I solved for x, right? I did that. Solve for x. Then it says write it as points. Remember, the whole point of solving a quadratic is finding its x-intercepts. So we actually found its x-intercepts. One of its x-intercepts is 2, 0, and the other one is, oops, I forgot the negative sign of this. This is a negative 9. The second x-intercept is negative 9, 0. Now we could have solved this quadratic by graphing it as well, right? I could set this equal to 0 and then graph it. I could get my graphing calculator out, I could graph it, and then see that the x-intercepts are 2, 0 and negative 9, 0. So I'll go ahead and show you that in Desmos really quick. Now remember, to graph something in a calculator, in Desmos, one side has to be equal to 0. So I have to make sure that it is equal to 0. I can't type in x squared plus 7x equals 18 because I can't do that. It won't do that. It won't do that for me, right? Like, it's like error. What the heck is this? So you have to make sure it is equal to 0 when you're graphing. So you have minus 18, right? So here's our quadratic. Now when you're typing it in your calculator, you don't type equals 0, obviously. So if I were to type it, and again, I'm using Desmos, not my graphing calculator, but if I were to use my graphing calculator, I would see on my table that I have 2 x-intercepts, negative 9, 0, and positive 2, 0. So again, we're solving for x-intercepts. So please make sure, because that's the most common mistake, is that you do not stop after you factor. That once you factor, then you solve it as well, because this is solving by factoring. All right, moving on to number 2. Again, the first step is, if we look at step 1, get one side equal to 0. Now, I will mention something kind of important. Just like keeping the x squared, the a positive in graphing, you want to try to keep a positive in this as well. So try to, if possible, keep your a positive. Okay, you want to try to keep a positive. So remember, a is attached to the x squared term. So you see how x squared is on this right-hand side? Since it's already positive 2, I want to keep it positive. If I try to move it to this side, it would become negative. So I'm going to keep it on that side. So what I'm going to do is I'm actually going to subtract 4x and move it to the other side. Instead of moving the x squared, I want to move everything else because I want that ax squared to continue to be positive. Which means when I do 4x minus 4x, on this left-hand side I have 0. Because the whole purpose is we want one side equal to 0. So then we have 2x squared minus 4x. Now this is in standard form, right? We have ax squared plus bx plus c. We're just missing that c, but technically, remember, it's technically a 0 back here, right? We have a 0, but we just don't need to write it. Now, if it bothers you, you can always flip it around and do 2x squared minus 4x equals 0 so that you're used to the way it looks. But again, you should always be able to do it in both ways. So I'm going to go ahead and factor this. So the first thing you do anytime you factor is what do you always check for first? You always check for a greatest common factor. Okay, so between these two terms, I only have 2 terms here, right? Remember, we're going to pretend like the equal 0 doesn't mean anything, so this will just stay there. But do we have a greatest common factor? Can I take something out of this? And I can. I can actually take out a 2x. So I can divide out 2 from both and factor out an x from both. So where does 2x go? 2x goes on the outside of my parentheses. Remember, GCF goes on the outside, and then your leftovers in the inside. 2 divided by 2 is 1, and then x squared divided by x is going to leave me with a single x. If I have 2 x's and I take away an x, I have 1 x left. And then I have negative 4 divided by 2, which is going to give me negative 2. And then my x's actually cancel each other out here. And then I close my parentheses. But again, you still have that 0 equals at the front or back, wherever you put it. All right, now once we get to this step, you want to check, can I keep going? Can I continue factoring? So how do you check for that? You look inside your parentheses. Inside your parentheses, you're looking, can I keep factoring this? The answer is no, because I no longer have a quadratic on the inside. There's not much left for me to do, right? If this was a quadratic on the inside with a square, I'd be like, okay, let's try to keep going. But because there is no exponent left, there's no square left, we can't keep factoring. So what's the step after you factor and you can't factor anymore? You're going to set all your factors equal to 0. So we did the first 2 already. Now we're going to set all of our factors equal to 0. Okay, well, we have 2 factors here. And I'm going to move this over. Oops. Copy that. Paste over here. Okay. So I actually have 2 factors here. And I know it doesn't look like it, but we do here. So one of our factors is 2x, right? So we're going to set 2x equal to 0. Okay, that's one of our factors. The other factor is x minus 2. Okay, and you're like, how 2x is not a factor, it's not in parentheses. Well, it doesn't have to be in parentheses. What was 2x? 2x was our GCF. What does GCF stand for? Greatest common factor. So 2x is a factor. It was actually our greatest common factor. So you set anything you have equal to 0. And then what do? Next? You solve for x. You're solving for x-intercepts here. So again, you don't want to stop at this step. People stop at the factoring step so much, but you don't want to stop there. You want to actually keep going and actually solve for those x-intercepts. So starting on this left-hand side, I have 2x equals 0. So how do I get x by itself? Well, I would divide by 2 because you want to do the opposite operation because 2 and x are being multiplied. Well, 2 divided by 2 cancels and becomes 1. So I have 1x equals 0 divided by 2, which is 0. And then I have x minus 2 equals 0. So I want to get x by itself, so I would add 2 to both sides. So I have x equals 0 plus 2, which is positive 2. So can I have x equal 0? Sure, I can have an x-intercept at 0. So that means our first x-intercept is at 0, 0. And our second x-intercept is at 2, 0. So if I were to graph this, I have two x-intercepts. One's at 0, 0, and one's at positive 2, 0. I actually forgot to box these answers. So here we have two x-intercepts as well. And again, I could have solved this by graphing. But again, we need to be able to use all types of methods to solve because sometimes one is easier than the other. Sometimes we don't have a graph handy and we can't actually graph it. So, all right, moving on to number 3. Now, number 3 looks a little bit different, doesn't it? We have x minus 3 and x plus 7. You're like, well, what am I supposed to do here, right? What do you notice? It's already factored for you, right? Remember, factoring is no distribution. So like we're undoing distribution, so they've undone everything for us. So typically when we have our final answer, when we factor, we have two sets of parentheses next to each other. Well, notice, oops, oh gosh, my iPad is freaking out. Oh my goodness. Notice that in this one, when we finished factoring, we have two sets of parentheses next to each other equals 0. My iPad is not saving anything. It's so strange. All right. And so in number 3, we have two sets of parentheses already equal to 0. So this is actually already factored for us, and all we have to do is set them equal to 0. So let's do that. So we're going to set x minus 3 equal to 0. Oops. And then x plus 7 equal to 0. Okay. Now, why am I allowed to do this? Because it's already factored. If I look inside both sets of parentheses, there is no exponent of 2 here. So I can't factor anymore, so it's already factored. Okay, next step here is you want to solve for those x-intercepts. After you factor, you solve for them. So to get x by itself, I would add 3 to both sides. Oops. So I have x equals positive 3. And to get x by itself here, I would subtract 7 on both sides to get x equals negative 7. So I have two x-intercepts here, positive 3, 0, and negative 7, 0. There we go. So we have two x-intercepts. Moving on to number 4, we have 3x squared equals 19x minus 6. Now, this one's not already factored, so it's going to be a little bit more work than number 3. But we want to make sure, hey, the first step is you have to have one side equal to 0 before you can factor it, because you have to have it in standard form. So everything needs to be on one side. It needs to be ax squared plus bx and then plus c. So the first thing I'm going to do is be like, okay, the question is, do I move 3x squared to the right, or do I move both of these to the left? Remember, you want to try to keep your ax squared positive. So remember, ax squared here is 3x squared. So your a here is already positive 3. You want to keep it positive. So you don't want to move it because it's already where we need it to be. So what I'm going to do is I'm going to move the 19x over and the 6 over. So I'm going to do this in one step. So I'm going to subtract 19x because it's already positive. I do the opposite. So I'm going to subtract 19x from both sides. So that will become 0. And I'm also going to add 6 to both sides to make this 0 as well. So I'm going to add 6 also. So I end up with 3x squared minus 19x plus 6 equals 0. Now you could have done two separate steps to get here, but I just went ahead and did them both in one step. It's allowed as long as your math balances out on each side. Now, once I have everything on one side and I have a side equal to 0, then I can factor. Just like with graphing, you can't graphing until one side is equal to 0. So once one side is equal to 0, then I can start factoring. The first thing I always check for before factoring is, do I have a greatest common factor? Do I have a GCF for my terms? The answer is no here. We don't have a greatest common factor. So we move on. The question is, what do I do? Right? Like, where do I go from here? Well, I know that I have 3 terms. And I know that in order to use AC method, I need 3 terms. So that's probably our best option here is to use AC method. So I'm going to go ahead and draw my x, a, b, and c. Now, you don't want to identify a, b, and c until it's in standard form, and we do have standard form here, so you want to make sure that it is in standard. Our a here is 3, b is negative 19, and c is positive 6. Okay, so we do ac on top, b on bottom. Okay, so a times c here is 18, b is negative 19. So I need two numbers that multiply to 18 but add to negative 19. Well, I know that negative 1 times negative 18 gives me positive 18, but it adds to negative 19. So those are going to be our two magic numbers here. So we have 3x squared is going to stay the same, positive 6 is going to stay the same, but that middle term splitting into two different terms. And we have minus 1x minus 18x. And again, remember the order of your two numbers doesn't matter. So if you want to put negative 18 first and then negative 1, that is also okay. We have equals 0 here. Oops. Moving on to our next step. Now that I have 4 terms, I can factor by grouping. So you split it into 2 groups and you continue with factor by grouping. So you're looking for your greatest common factor between your first group here. The greatest common factor here would just be 1x because that's the largest thing I can take out of both. So I have x left over. And then 3 divided by 1 is 3, because remember there's technically a 1 here. And then I have 2 x's and I take away an x, so I have an x left. And then I have negative 1, because negative 1 divided by 1 is negative 1. And my x's cancel, so I close my parentheses. I also need to shrink this a little bit because, or not shrink it, but move everything up so that it fits and I have room. All right, moving on to my next group here, I have negative 18x plus 6. The largest number I can take out of both is a 6. I can't take out any x's because 6 doesn't have any x's. But because that first term is negative in the group, I must take out a negative 6. So I have negative 6 outside my parentheses. Negative 18 divided by negative 6 is positive 3, and I have that x left over. And then 6 divided by negative 1 is, or negative 6 is negative 1. And then again, I still have that equals 0 there. That's important for solving. Now, always check to make sure your parentheses match, because if their parentheses don't match, then we need to go back and figure out what we did wrong, right? So it's always important that they match each other. Okay, so our next step here is you're going to take your two GCFs and shove them into one factor. So one of our factors here is x minus 6. And then our other factor, what color have I not used? I haven't used blue. Our other factor is going to be 3x minus 1. And again, that's all equal to 0. Now, once you finish factoring, remember, when we're finished factoring, I'm trying to move this all up. When you're done factoring, you're going to set them equal to 0, right? We're solving for our x-intercepts here. Right here, we haven't solved for anything. We literally just factored. So you want to make sure you don't stop at this step because it is a common step to stop at. So I'm going to move this here because I've run out of room. Are you going to set both of your, all any of your factors? So sometimes you might have 3 factors, sometimes you only have 1 factor, so it just depends on the problem. But I'm going to set all of my factors equal to 0 here. I got to figure out what color I haven't used yet. I think I've used almost literally everything, so I haven't used this color. All right, so one of our factors here is x minus 6, and we're going to set that equal to 0, and the other factor is 3x minus 1 equal 0. All right, so now I'm going to solve for x in both situations. So in the first situation over here, the first step would be to add 6 to both sides, and I get x equals 6. And over here, 3x minus 1 equals 0. So the first step I would do to get x by itself is add 1 to both sides. So then I have 3x equals positive 1. But here, x is not by itself yet. So what's our next step? We have to divide by 3. So get x equals 1/3. So what does that mean, right? Like what does that mean for us? And I think I need to move this up a little bit more. Boop. All right, so what does that mean? It means we have 2 x-intercepts again, but just one of them happens to not be the whole number. So one of our x-intercepts is 6, 0. And the other x-intercept is 1/3, 0. Now you're like, that seems kind of strange. Like, why would I have a decimal? But remember, not all your x-intercepts will always cross at whole numbers. Occasionally, they'll cross at fractions. So I'll go ahead and show you. Now, if I want to graph this, it has to be equal to 0. So I can't just type in 3x squared equals 19x minus 6 on paper, right? On your paper, that's what it says. So everything needs to be equal to 0. So I'd have to have 3x squared plus 19x. Oh, sorry, minus 19x. Minus 19x plus 6. Now here you'll notice that the quadratic crosses the x-axis twice, one at positive 6 and the other at 0.333 repeating. Now remember 0.3 repeating as a decimal, or 0.3 repeating as a fraction is 1/3. So we do have that 2 x-intercepts. One of them just happens to be not a whole number. All right, moving on to the next one, we have 9x squared equals 16. Remember, first step into solving or any type of factoring, you want it in standard form. So you want everything on one side, and one side needs to be equal to 0. Now, the key is you want to keep your ax squared positive. So here our x squared is already positive. We have positive 9, so you want to keep it over there. So we're going to move the 16 to the left side. So in order to do that, we're going to subtract 16 on both sides. So you do the opposite to get rid of it. So you have 9x squared minus 16 equals 0. Okay, so one side is equal to 0. Now the next step here is you're going to look for your greatest common factor. Do you have a GCF? Answer is no here. We don't have a greatest common factor. So now what do we do, right? Well, if I don't have a greatest common factor, I'm stuck. I'm like, well, I only have 2 terms. How am I supposed to do AC method with only 2 terms? You're like, well, the question is, can you even keep going here, right? Like, can we even keep factoring this problem? Because I know that the GCF is 1, but can I keep going anywhere? The answer is you should always try. If you see that there's an exponent of 2 left, you always try and keep going. So the problem is there's only 2 terms. So how do I make this into 3 terms? Well, I notice this is in standard form, but I'm missing one of my terms. I'm missing my b. So this is one of those special cases. So we actually are missing our b terms. We have 9x squared. Our b here, because it's missing, if it's not there, remember nothing as a number is 0. So we have 0x minus 16 equals 0. So that b was missing. Now I can do AC method because now I have 3 terms. You can't do AC method if you only have 2 terms. So I'm going to go ahead and identify A, B, and C because I have it in standard form already. A here is 9, B is 0, and C is negative 16. Oops. Okay, so A times C here I think is negative 225 if I'm not incorrect. Let me double check this on calculator. 9 times 16. Oh, it's 144. Yeah, that's off. All right, so that's negative 144. Double check that one more time. Oops, 9 times 16. Yeah, 144. All right, and then our b here is 0. So I need 2 numbers that add to 0 but multiply to negative 144. Well, this is a special case. The only time for 2 numbers to add to 0 is if they're the exact same. So I need 2 numbers that are the same but opposite signs that multiply to negative 144 but add to 0. Now, sometimes people like to do negative 144 and positive 144. I mean, yes, they equal 0 when I add them up, but when I multiply them, does it give me negative 144? No. So negative 12 and positive 12 multiply to negative 144, and they add to 0. So those 2 numbers really do matter what you pick. You can't just pick literally any 2 numbers. All right, so we have 9x squared minus 16 equals 0. Oops. And then we have our 2 x's here that we split up, negative 12x plus 12x. Now, once you have 4 terms, you can solve by grouping. Factor by grouping, I'm sorry. All right, so in our first group here, we want to look for our GCF. Well, the largest number that goes into both is 3, and the most amount of x's I can factor out is a single x. So we have 3x. We factor that out. We have 9 divided by 3, which is 3. X squared divided by x, which is a single x. I have 1 x left over. And then negative 12 divided by 3 is negative 4, and if I have an x and I take away an x, they cancel. So I close my parentheses. Moving on to the second set of parentheses, or second group, I'm sorry. We are looking for our greatest common factor, and our greatest common factor here is 4, because that's the largest number that goes into both. I can't factor out any x's because 16 does not have any x's, and I do not have to factor out a negative because our first term is not negative, so it would be a positive 4. So you want to put a plus 4 there so you remember that that is a positive 4. And then you open up your parentheses to your leftovers. 12 divided by 4 is 3, and we have that x left over. And then negative 16 divided by 4 is negative 4, and we close it. And again, this still equals 0. Keep that equals 0 on the back end. I know it seems silly to keep it on there, but it is important because we don't want to leave it off on accident because it's still important to us. All right, so our next step here is going to put our 2 greatest common factors into one set of parentheses. So 3x and 4 are going to go into a factor together. So 3x plus 4 is one of our factors. Our other factor is 3x minus 4. And this equals 0. So we have finished factoring, but we have not solved anything. We want to solve this. In order to solve this, you want to solve by setting each factor equal to 0. So we have 2 factors here, 3x plus 4 and 3x minus 4, so we're going to set them both equal to 0. What have I not used? I'm going crazy. Have I used red? I have not used red. So we're going to set one of our factors. So one of our factors is x plus 4. We're going to set that equal to 0. And then the other factor is 3x minus 4, and we'll set that equal to 0. So all factors get set equal to 0 because we're solving for our x-intercept. We're solving for x here. So you're trying to get x by itself. So on the left, the first thing I would do is subtract 4 from both sides. So 3x equals 0 minus 4 is negative 4. And then try to get x by itself, I would divide both sides by 3. So I have x equals negative 4/3. Okay? And then in the other set, or in the other factor, I want to get this equal to 0, or not equal to 0, solve for x and get it by itself. I would add 4 to both sides. So if 3x equals positive 4, divide both sides by 3. 3's cancel. I get x equals positive 4/3. So if you look at your answers, we have negative 4/3 and positive 4/3. Kind of interesting. All right, so one of our x-intercepts is going to be negative 4/3, comma 0. And the other x-intercept is 4, comma 3, or 4... I can't speak today. Our other x-intercept is 4/3, comma 0. So our two x-intercepts are here. Okay, so again, you're solving for x-intercepts, so make sure you do that final step of actually solving it. You don't want to stop too early and not solve it, because that would be very bad, because then you technically haven't solved it, you've just factored. And you haven't really done the problem completely, so you want to make sure you do the whole problem. And I'm going to move these down here. Why not? Okay, moving on to number 6. Now, if you notice in number 6, this has a set of parentheses already for us, which leads me to think maybe they already factored this for us. So let's check. Looks like they took out a GCF of x. Let's look on the inside. Can I keep factoring? Answer is no, because there isn't a squared here, right? So I can't keep factoring. So they've already factored for us. We don't have to factor. All we do is set those factors equal to 0 because we're solving for that x-intercept. So one of our factors here is actually just x. So we have x equals 0. So even though x is just the greatest common factor, it's still a factor, so you're going to set that equal to 0. Then your other factor is 4x plus 1. You're going to set that also equal to 0. Now, x equals 0 is already by itself, so I don't need to keep going to solve for x, right, because it's already by itself. But in the other one, x is not by itself yet. So first thing I would do would be to subtract 1 on both sides. So I have 4x equals 0 minus 1 is negative 1. Okay, well, to try to get x by itself, I would divide both sides by 4. So my 4's cancel, and I get x equals negative 1/4, or negative 0.25. So I have two x-intercepts here. One of my x-intercepts is 0, 0, because x was equal to 0, which means it crosses at the point 0, 0. The other one is at negative 1/4, comma 0. So I have two x-intercepts. One's at the origin at 0, 0, and the other one's at negative 1/4, 0. Again, if I didn't have to factor in this one, so it's not really much I had to do. Okay, moving on to number 7, 15x squared minus 25x plus 10 equals 0. Now this one's special. Now, I'll show you why it's special in a little bit, but, oh, I totally forgot to mention. Number 6 already had 0 on one side by itself, so that's a good indicator that it's already kind of set up in a way for you to start already without having to do much work. All right, number 7. First step is you want one side equal to 0. I got that, right? And we want x squared to be positive. X squared is positive. It's 15 here, so we're good. So things are looking good so far. Now we're going to go into solving by factoring. Now to solve by factoring, the first thing you do when you factor is you look for a greatest common factor. Do you have a GCF here? Yes. So this one is special because you do have a GCF here. And so you want to keep that in mind. Like, all right, I have a greatest common factor. So let's take that out. So we're going to factor out a 5, because 5 is the largest thing that goes into all terms. It can't take out any x's because 10 doesn't have any x's. So 5 is going to go on the outside of my parentheses, and I'm going to start simplifying this. So I have 15 divided by 5, which is 3, so I have 3x squared. Negative 25 divided by 5 is negative 5, so I have negative 5x. And then 10 divided by 5 is positive 2, and then I have equals 0. Oops, there we go. Okay, so I've taken out my greatest common factor. Now remember when we take out that GCF, we don't really want to think about that GCF till the very end. So I'm going to make a note to myself that I took out a GCF of 5, but that's not super important till the very end. So I'm just going to pretend like it's not there for now. All right, now look on the inside of my parentheses. Can I keep going? Can I keep factoring? Answer is yes. I still have a squared there, so I can keep factoring. Do I need to do any extra work, or can I just go straight into AC method? I can actually just jump straight into AC method because I have 3 terms. I know that AC method I need 3 terms, so I'm set up all good to go for that. So I'm actually going to make this a different color so I can color coordinate this better. All right, so we're going to do AC method over here. and it's already in standard form, which is lucky us, right? A is positive 3. Remember, we're going to pretend like that 5 isn't there. B is negative 5, and C is positive 2. So A times C here, remember AC goes on top, B goes on bottom. Did I put that on my other X? I did not. AC, B. All right. AC here, so A times C, 3 times 2 is 6, and B is negative 5. So I need two numbers that multiply to 6 but add to negative 5. Well, those two numbers that would be, now I'm like, well, 3 times 2 is 6, right? 3 times 2 equals 6, but it doesn't add to negative 5. So in order for it to be adding to negative 5, I would need to have negative 3 and negative 2. Negative 3 times negative 2 makes positive 6. Negative times a negative makes a positive, but they also add to negative 5. So we know that our first term, 3x squared, is going to stay the same, and we know that positive 2 is going to stay the same, but we're splitting that middle term up. So we have negative 3x and negative 2x. Now remember, the order doesn't matter, so if you want to put negative 2 first, you can do that as well, and you'll get the same factors in the end. Equals 0. Once you have 4 terms, you can now factor by grouping. So in our first group here, I'm going to factor out the largest thing I can. So the largest number is 3, but I can also take out an x. So the largest number is a 3, largest variable is an x, so GCF is 3x here. Now 3 divided by 3 is 1, so I technically have a 1 left, but I don't usually write that 1 unless I have to. And then x squared divided by x is going to leave us with a single x. Negative 3 divided by 3 is negative 1, and x divided by x cancels. So I do have to write this 1 because there is not a variable attached to it. Remember, the only time you don't have to write a 1 is if there's a variable there. If there's no variable, you need to write the 1 there so that we know that the 1 is there. If you don't write it, then it looks like 0, so it's important that you write it. All right, moving on to the next group. The largest number that goes into both is 2, but because the first term is negative here, you must divide out a negative 2. So you have negative 2 here, in parentheses, negative 2 divided by negative 2 is positive 1. So I have positive 1x, and again, I don't have to write that 1 because there is a variable present. 2 divided by negative 1, or negative 2 is negative 1. And again, that equals 0 is still there. It's still tacking on. It's still important to us, so we're going to keep it there. All right, the next step here is we're going to take our two GCFs and put them into a factor together. So 3x minus 2 is one of my factors. And then the other factor is x minus 1. And then we have equals 0. So is this our final factored form? No, because we still have that 5. Do you remember that GCF of 5? So we want to remember that GCF is still there. That's why we reminded ourselves at the very end, like, hey, we had a GCF. We pulled it at the very beginning. So what do you do now? Well, you do the same thing you always do. You're going to solve for your x-intercepts because this isn't factoring. We're solving by factoring. So we've got to do some type of solving. All we've done is factor here, right? We want to actually solve something. So let me find what color. I don't think I've used, oh, I have used blue. What have I not used? Decisions, am I right? All right, we'll just use this for now because I can't figure out what else we haven't used. I think we've used pretty much everything. All right, now here, this one's different. We have 3 factors. One of our factors is 5, right? Because that's our GCF at the beginning. So a GCF stands for greatest common factor. Because it's a factor, you still set it equal to 0. So we have 5 equal to 0. I know that looks funny, just don't question it for a second. And then we have 3x minus 2 equals 0. And then we have x minus 1 equals 0. So we have 3 factors here, and we set them all equal to 0. Now, you're going to continue on, and you can actually solve to get x by itself. Now, if I look at this, 5 equals 0. Can 5 equal 0? Does that even make any sense? No. So this solution is actually voided because it doesn't make any sense, right? It's not possible. 5 can't equal 0, so solution doesn't matter. Now, you're like, well, how come I didn't do that earlier when I got equals 0? Well, let's see in this one. We had 2 factors, and we had 2 factors here, so we did 2x equals 0 and then x minus 2 equals 0. Here there was an x to solve for. We got x by itself. So there's an x here. X can equal 0 because you can have an x-intercept at 0, 0. So x can equal 0, but 5 can't equal 0. You can't have a number equal 0 because that's a number. Like, it has a set value. You can't have it equal to 0. Now, x can equal to 0. This is okay, but you can't have like 3 equal to 0. Not okay. So that's why sometimes it's okay to have it equal to 0, sometimes it is not. So you want to be very careful about that. 5 can't equal 0, so that solution is voided. So if there's an x present, keep that number. If there's no x left, it gets eliminated. So because there's no x involved here, it doesn't matter to us. So then we move on to the next solution set, which is 3x minus 2 equals 0. So we're going to get x by itself. I'm going to add 2 to both sides. We get 3x equals positive 2. Okay, then we divide both sides by 3 to get x by itself. So we get x equals 2/3. Okay, so that's one of our x-intercepts. And then the other one, we would try to get x by itself. We would just add 1, so this one's pretty easy. X equals 1. So we have two x-intercepts here. 2/3, 0. And then we have 1, 0. So our quadratic crosses the x-axis twice at 2/3, 0 and 1, 0. So that is the section for factoring. We have one more word problem left.